Hello viewers, welcome to my channel Learn Electrical Engineering 121 Pod. In today's session, we'll start learning the concepts of control systems. Now, to start with, we'll just brush up the basic fundamentals. Now we'll learn what a system is. A system is a combination of different elements placed in a particular order to perform a specific task. Then you call it as a system. Now, coming to a control system. Now here, when an input variable is being varied to control the output, or in simple sense, the output variable is being controlled by varying the input, then you call it as a control system. Then, how do you represent a control system? Then there are various ways in which you represent control system. But the very basic format is in terms of block diagram representation. This is the block representing a system here, where you have an input and then followed by an output. This input, you call it as a command signal or excitation. This output, you call it as controlled variable or response, because you call this as a control variable because you're controlling this output variable by varying this input. Only then you call this as a controlled variable or response. So this is about a system, a control system, the way you represent a control system. Now we'll see the various types of systems. In general, you have different systems, like you have mechanical systems. Depending upon the nature, we have mechanical, electrical, hydraulic, etc. etc. Now, these are the various systems. You have a lot more systems, but just to mention few, we have different sorts of system depending upon the nature of inputs and outputs we obtain. Now, coming to the electrical systems. We have several types of electrical system. Let's see what those are. Now we'll see the different types of electrical systems. Now here we have linear system and non-linear system. In linear system is a system where the output variations are in proportion with the input changes, then you call it a linear system. Or in another sense, here in a linear system, this particular system holds good the principle of superposition and the principle of homogeneity. Now in case of nonlinear system, the output variation are not in proportion with the input variations, then you call it a nonlinear system. And here the principle of superposition and the principle of homogeneity does not hold good. And most of the systems in nature are nonlinear. Now, again with respect to time, we do have two sorts of system. One is time invariant and one is time variant. In time invariant system, the output is not dependent on time, or else we can say the output variations are independent of time. Now, time variant systems are systems where the output changes according to the time instant. As the time changes, you can observe the output changes with respect to input given. That you call it as a time variant system. Now, depending upon the number of inputs and number of outputs, we do have another type of systems. Those you call it as single input, single output system and multi-input, multi-output systems. For example, the very first case, single input, single output. That is, for example, you have one input, you have one output, then you call it as a single input, single output system. If you go for multi-input, that is, you have n number of inputs here at this input end, where you have n number of output here at this output end, then you call it as a multi-input, multi-output system. Now, depending upon the convenience of operation and the complexity, we do have two sorts of systems here, open loop system and a closed loop system. Let's see what these are. In an open loop system, this is the way how we represent it. This is a system where we have an input and output. Now here in this system, to obtain the output, we have to manually change the input. Okay. Now, we can't expect the desired output. For example, we do have a certain value of desired output. We can't obtain every time our desired output, because the only problem here is there is no kind of modification here where you can't modify the input given to this particular system. So definitely this particular system is, though it is very simple, it's not reliable because you can't get your desired output here. This is about open loop. Let's see what a closed loop system is. Now you can see here you have a system representation here. One is forward path and one is the return path here. In the forward path you have an input here followed by a controller, then an open loop system followed by an output. There is a return path here from the output point. Okay, you call this as a feedback path. Okay, now let's see what happens in a closed loop system. Once you give an input to a particular system, then it is given to a controller, then to an open loop system, then you get your desired or whatever the output, you get certain output here. Now here what happens is, because of the feedback path, this feedback path would try to transform the output signal to the known format or the same format of reference input, so that the reference input and the signal coming here is being compared, or whatever the error being sensed between these two signals is obtained by the error detector here, and that is being fed to the controller. What this controller does is, it modifies the signal here, then gives it to an open loop system so that you get your desired output. This is a continuous process happening here until you get your desired output, or your obtained output would match with your desired output value. Okay, now in this particular system, this is a bit complex but yet reliable. Only problem here is you have to design it that neatly so that you don't end up with an oscillatory system here. The feedback system should be designed properly so that you don't end up with an oscillatory system. That is the only problem. It's a bit costly, complex, but yet the task to be done. For that reason, you definitely have to opt a closed loop system where you need not all the time going for manual updation. Here you can go for an automatic system, or in a simple sense you can conveniently get your desired output, and it is a reliable system. So in today's session we have seen different types of control system. We have seen what a system is, what a control system is, different types of systems, that is mechanical, electrical, hydraulic, whatever, you have several sorts of system, biological system. Everything in the world is definitely a system. Now most of the systems in nature are non-linear, and here when coming to a control system, To start with, we have an open loop system and a closed loop system. We have seen how you represent a closed loop system and a open loop system and the differences between those two. In the coming session, we'll see this open loop system and a closed loop system in detail with example and how it works. That's it for this lecture today. And next session we'll see more in detail. If you do have any suggestions or queries, please do mention in the comment box below. Thank you for watching. If you find this video helpful, please like, share and subscribe. Stay tuned for more videos.